All right, guys, so I have to give you some congratulations here before we get started. Once you have finished this video, you will have finished the last new topic that you will ever learn in Math 146. You will also finish the last topic in the probability unit. So hold on tight. We are almost done. So something else I want to mention, this topic in the probability unit is really the only topic that isn't just straight probability. You're not just going to be writing fractions or decimals here. But to me, it's the most useful topic in this unit. So, just to get you started, here's the book definition of expected value, which is also called a weighted average. You may be a little more familiar with that term, but it's a predicted value of a variable. So, we're predicting something in the future, and it's calculated as the sum of all possible values. So, we're finding all the possibilities and adding them together, each multiplied by the probability of its occurrence. So that's really wordy. So let me kind of give you an example of that. Expected value or a weighted average is the way that pretty much all of your teachers calculate all of your grades. So for example, when I go to Infinite Campus, your tests don't count the same amount as your quizzes do because tests are longer than quizzes. So how do I calculate your grade? Well, I say, okay, your test count for, I think in this class it's 28% of your grade. So I would take 28% times whatever your test average is. Then I would add that to 10% times whatever your quiz average is, because quizzes count for 10% of your grade. And I would keep going through all the categories. So here's the thing. Expected value, or a weighted average, is something that's used anytime things are weighted differently, okay? So think back to like middle school when you learned how to do an average. All you had to do was add together something and then divide it, right? Well, that was because all of those things counted the same. So like if I give you 5 test scores and say calculate your average, all you have to do is add those 5 test scores and divide them by 5 because each test counts the same. But if I tell you to go calculate your entire grade, quizzes and tests don't count the same, so you can't do that. That's what expected value is for. The other thing that it's used for is it helps you assess risky investments, including gambling. We'll talk about that a little bit down here in a minute. So here's just a quick example of how I calculate your grade in this class. It's also an example of how you do expected value. So in Math 146, there are 5 different categories, and they're listed right here. They all have different weights, and they make up your grade when I combine them. So this table right here shows your grade in each category, okay? I made those up, but that's labeled as X, so these are all your grades in each category, and it shows the percentage of your grade that each category counts for, and those are listed right here under P of X. P of X can stand for probability, or it can stand for percentage. The question is, what is your expected grade at the end of the semester? Well, to find that, here's what I do. 20% as a decimal is 0.20. So I take 0.20 times the 85 that you got in the exam category. Then I look at your homework category and I say, well, what'd you get that? Okay, well, you got a 91, and that counts as 22% of your grade. So notice I'm adding together, okay, that weighted part of each category. Then I add your project part. I say, okay, well, you made a 95 overall on your projects, and that counted as 20% of your grade. Then I go to quizzes. Quizzes count as 10% of your grade, and you made an 80 on them. And then tests count as 28% of your grade, and you made an 83 on those. So notice what I did here. I multiplied every single time the percentage by the category. The percentage by the category, and then I'm adding together all of those values. And let me get Desmos here because I cannot do that off the top of my head. Okay? But you're just going to type this in like you would any normal, multiplication and addition problem. Okay? So we've got 0.20 times 85 plus 0.22 times 91 plus 0.20 times 95 plus 0.10 times 80. And then finally, plus 0.28 times 83. And right there, you would expect at the end of the semester to have an 87.26. Okay, so if you've ever wondered why when you go to fix your grade, like maybe you have a missing assignment and you turn it in and it doesn't do a whole lot to raise your grade, that's why, because assignments in a lot of classes don't count nearly as much as a test. So in all honesty, raising your test grade by 5 points might even do more than raising your assignment grade by 10 points in a lot of classes. So keep that in mind. All right, let's take a look at example 2. So this one is not in table form. It's going to be written out almost like a word problem. But it says there's a bag and it contains 12 balls in it. You've got 5 that are red, 3 that are green, and the rest that are yellow. In this game, you get to draw one ball from the bag. You will win $14 if you draw a red, $12 if you draw a yellow, but you will lose $16 if you draw a green ball. How much do you expect to win or lose if you play this game? So think about what expected value or a weighted average is. You're taking the percentage, or in this case, we're going to use the word probability, times the value. Okay? So let's start with the red balls. What's the probability that I draw a red ball? Well, it's 5 out of 12. Okay? What happens if I do draw a red ball? I win $14. So that takes care of the red scenario. Now I'm going to add that to what happens in the yellow scenario. What's the probability that I draw a yellow ball? Well, let's see here. 5 are red, 3 are green. That means there are 4 left over that are yellow. So the probability of me drawing a yellow ball is 4 out of 12. And if I draw a yellow, I win $12. So there's my yellow scenario. Then lastly, I go to what happens if I draw a green ball. Well, there are only 3 green balls, so the probability of drawing a green is 3 out of 12. What happens, though, if I draw a green ball? Well, I actually lose $16. So that 16 there is going to be negative. That's the biggest mistake people make on these problems is they forget a negative. So don't forget about that if you're losing money. So then I go to Desmos and I type it in. So I have 5 over 12 times 14 plus 4 out of 12 times 12 plus, let's see, what was that last one? Yeah, 3 out of 12 times negative 16. And right there's your answer, okay? So here's the thing. What this means is on average, not that it'll happen every time, but on average you would expect to make about $5.83 every time you played this game. Now, sometimes you're going to lose $16, sometimes you're going to win 14, sometimes you're going to win 12. So you're never actually going to make exactly $5.83. But if you played this game over and over again, on average, that's what you would expect to win. Now, something else I want to point out. See how it says how much do you expect to win or lose money? If you end up with a positive number as your final answer, then you expect to win that money. However, if you end up with a negative number right here, then you expect to lose it. Okay? So there's example 2. Very last one here. At Tucson Raceway Park, your horse, soon to be Glue. I hate that name. I should have changed that before I typed this out. But anyway, your horse has a probability of 1/20th of coming in first place, so not great. Probability of 1 out of 10 of coming in second place, and a probability of 1 out of 4 of coming in third place. Okay? And then it tells you how much money you win for each place. And the question is it worthwhile to enter the race if it costs $1,000? So again, we take the probability that your horse wins times the amount that you get if he does. So what's the probability he gets first place? 1 out of 10. And if you win first place, you get $4,500. So that takes care of the first place scenario. Then we add that to second place. His probability of winning was 1 out of 20. Your probability of coming in second is 1 out of 10. And what happens if he wins second place? Well, you get $3,500. All right, then we look at third place. Probability of coming in third is 1 out of 4. And if he does, he wins $1,500. Now, here is the extra step here. It says, is it worthwhile to enter the race if it costs you $1,000? Well, if it costs me $1,000, that means right up front, I'm losing $1,000. So I have to subtract that out. So anytime it tells you that you're playing a game and it cost you something, anytime you're dealing with insurance or something like that, and it tells you you have to pay this out of pocket, you're going to subtract that amount because that's coming out of your pocket off the top no matter what happens. So our question is it worthwhile to enter the race? That's what we're going to find out. So now we go to Desmos and we type it in. So 1 over 20 times 4,500 plus 1 over 10 times 3,500 plus 1 over 4 times 1,500. But then we got to subtract that $1,000 out because of the entrance fee. And look what we get. We get negative 50 here as our expected value. And we'll put a dollar sign there just so we remember we're talking about money. So here's the thing. If it wasn't for that entrance fee, then I'd say, yeah, go for it, enter the race. But that $1,000 at the end means that I'm actually expected to lose $50 on this race. Okay? So is it worthwhile? It's up to you. Okay? Just because you get a negative doesn't mean you can't enter your horse in the race. If you're super confident that he's going to win, I mean, you could come home with $4,500. But on average, you would not expect him to win. You would actually expect to lose $50 on average. Okay? So there's expected value in a nutshell. Go ahead and get started on today's quizzes, and please let me know if you have questions.